I don't often start my talks with a warning or a disclaimer, but this is the most over-engineered conference, as Hans has told us, and I reckon this may be the most over-engineered architecture and talk that you're going to see at this conference, too. With that, can I kindly ask everyone to raise their hands? Thank you. If you're not using Kubernetes, you can put your hand down. If you're not getting any microservices, you can put your hands down. If you're not using GraphQL, you can put your hands down. Always the same. Kubernetes is well adopted in 2025, right? We're over 10 years in at this point. If you're on Kubernetes with a monolith, you're probably having just as many problems as you had with a monolith before Kubernetes. So the chances are you also have microservices too. But nobody's using GraphQL, at least what I see in the cloud native community and people that are building back-end systems. There seems to be more things that are adopted with major companies like Meta, who invented the concept, but I'm not seeing widespread adoption. And I want to try and change the opinion of how we can use GraphQL for service composition with microservices. To the point where I want to push it to this extreme example of, well, what if a microservice was a single column in a database? And this is over-engineered. I am very lucky. I work for myself on the Raw Code Academy, so I am the one that is responsible for any outages. I'm the one that's responsible for data migrations, anything like that. And I use this as a test bed because when it's my responsibility, I want to make it fun to be building what I'm building. And I do over-engineer it in the name of education to see, can we find new architectures that make some of the more challenging things with microservices easier? Because when we were promised microservices, we were told that we would write small services that would be easy to fit in our heads. The problem is that complexity doesn't disappear, right? We're pushing it down to the platform and infrastructure layer where we have to have service discovery and we have to have retries and build redundant and resilient services and so forth and so forth. To the point where some people think I'm crazy when I talk about this idea, and that's okay. This is not something that I want people to walk away going, well, every column is a microservice. What I want you to walk away with is the idea that when we talk about working with microservices, that this is an option and a pattern that we can adopt. With that being said, I am David Flanagan. Please check out the Raw Code Academy. There's now over 600 hours of content there, mostly around Kubernetes, and if you've ever seen the CNCF landscape document, quite big, I have covered a large chunk of that. So if you ever need to learn a new technology, check it out. Hopefully you find something of use. And if you have something that's not covered there, just come and talk to me. I'm always looking for new ideas of new things to cover and hopefully make it easier for everyone. So let's take a look at traditional microservice boundaries. This is my contrived service called BitHub. It has issues and comments and projects. We work with these entities every single day, right? We add issues, and we can create project boards. We comment on issues. It's how we communicate as developers. But even GitHub are extending this now to add new functionality and new features. And GitHub are actually one of the major companies that do support GraphQL natively on their API, which is very cool. Now, they've decided that projects actually have a status. You know, a project can be cancelled, it could be in planning phase, it could be behind schedule. There are lots of different things that we need to understand about the status of a project. And the way that we do this traditionally is, well, we start working on some sort of SQL migration. And we need to add a new column to a service. And in this case, this could be really simple. It could just be that we have a varchar, and we say 50 as a max, because that seems sensible. Possibly you decide it's an enumerated value. We know the state's up front, and we want to build that. But you know, whatever it is, we're adding a column. However, anyone who's been doing database work for more than a few years knows that actually changing the schema of a database table it's not overly complicated, but it is complex, and that there are a whole bunch of rules and heuristics that we have to follow to make sure that we do this in a safe way, that we aren't going to break backwards compatibility. We can do rollbacks, lots of different failure scenarios that need to be accounted for. This is just one example of one of those failure things, but you know, there are things as table locks. Depending on the changes that you make to the table, you may have to lock the entire table for a microsecond, a millisecond, whatever. Could be seconds, depending on how large that table is, how much data it is, do we have to rebuild indices, et cetera, et cetera, et cetera. So while it's not a huge problem, again, you have to be aware of all these challenges before you just throw a SQL migration to a database. And the table locking is, again, is one of the simpler things that we can account for very easily with a small set of rules and heuristics that we know. But we also have all these other rules. We can never rename a column because then we can never roll back our service, right? This is just a golden rule of anyone who has worked with a database. We definitely never change column types because, again, that causes a lot of challenges. Can't remove columns. So everything here is just we need backwards compatibility. And in a microservice architecture, we're trying to avoid that in general because we always want to roll forward. This is one of the, the things that we've been preaching and practicing as we evolve to microservices or any service-oriented architecture. No, not the point. I'm not here to talk about SQL migrations. I just wanted to highlight one of the challenges with the way that we extend and make modifications to our services today. Now, instead of modifying the microservice, there's also this other thing that we've been told over the last 10 years, is that it's easier to rebuild. Now, why would we change something when it's less than whatever number of lines of code, right? We all think micro is. No one's ever defined what a microservice is, but we know it's supposed to be as small as possible. We rebuild it, or we just create a new one. But I think that composition, actually, an extension via microservices is the preferred approach. We shouldn't really rebuild something. We're extending something. And that's to the point of, well, what if we do want to add the status to our project service, but we want to do it by adding a new service? How can we make this work? And it's not exactly one column, right? The status is the most important thing, but we may track when it was updated. And of course, we still need referential integrity at a service composition layer, so we still have a project ID. We still need to be able to treat this as data, real and safe data, correct data. So we can spin up a new service to do this, but we need to make sure that the read path for this service doesn't become the bottleneck of how our application works. And this is where GraphQL Federation comes in. Is anyone aware of GraphQL Federation today? Okay, only a couple of hands. So here's a quick diagram of how this works. A client query comes in, and I'll show you an example of a client query shortly. And it goes to something called a router. All right, you're probably more familiar with the concept of an API gateway, right? This is how we do it in the REST landscape and other patterns, but we call it the router for GraphQL because we have to build a syntax tree, break it down, do entity resolution, a whole bunch of other really smart things at the router layer, and then eventually we pass these requests on to the downstream services. So for the projects, we're fetching all the projects, the issues, and then the status. But we do have to then stitch all of this together to return a single response. And there are a lot of challenges in doing this. When it comes to GraphQL Federation, this is definitely the trickiest part and the most complicated part of the whole thing is the router. The reason I mention that is what I would say is don't go and build your own router to do this. That is definitely a step too far, and the Federation specification is very, very complicated. Fortunately for us, there are so many different open source ways and routers available that you can just go and adopt. The one that I'm using today is called Cosmo. It's written in Go, which means it's cloud native by default. But there's also the Hive router, which is written in Rust. There's the Apollo routers, which is written in Rust. And there's actually a whole bunch of smaller ones in proof of concept. So the tooling is this. You just have to go and take a look and find the one that is right for you. Now, to make Federation work, we have to use this GraphQL syntax here to define our entities, and we have to tell them how they can be resolved by the router. So for our project, this is a type with the properties that you see below. The exclamation mark just means this is a mandatory field. We can never have a project that doesn't have an ID and a name or a created at, but the description is optional, so there's no exclamation mark. We have a complete type system in GraphQL, from strings, integers, enums, interfaces, everything that you could do basically with like a traditional OOP language, you can do with GraphQL's type system as well. Now the @ symbol on our type is our first directive, and we're just saying that this entity is keyed by a value. All that means is that if the router ever needs to find a project, it must have these fields. And this is the most simplest case where we just say if you have a project ID, we can return the project entity. This is a very sophisticated system, and you can use composite keys depending on how far you break down and decompose your services. For a project, I'm not going to have a good example, but for a project issue, you're going to need a project ID and an issue ID, a composite key to fetch that one specific issue or do entity resolution for that one specific comment. Now, provides is a tricky one, but it is a very important one. This allows us to give hints to the router to avoid N+1 problems and entity resolution in GraphQL. Everybody talks about N+1 when they talk about GraphQL. If you're not familiar, that is, you can essentially denial of service attack your own API by doing nested entities and a very infinite recursion all the way down, causing your router to blow up and all of your traffic to go away. Not something that you want. Fortunately, every single router that I mentioned has complexity analysis and can block those type of requests. But also the provides directives allows us to give hints to the router to say this information may canonically live here, but we can resolve it in other services so that we can actually have denormalized views and independent services resolve specific paths. I tried to show an example of how this is used from the Raw Code Academy when we get to the demo at the end. But this is used as a way to improve performance and avoid N+1 problems and have better cache hits for certain queries within your subgraphs. Now, the way that this is used here is that we can say entity resolution. Oh, sorry, this is requires. Where's my other one for? Oh, I got a slide in the wrong place. The way that this is used here is you could just have provides annotation on your query and say that we don't normally have status on a project, but we're going to have a cache value that this subgraph can resolve. Again, I'll try and show an example of that later. Now we'll go back to this one. The requires directive is how we say that we can resolve certain information, but we need enough information up front. So when we query the project graph, in fact, this is actually, there's quite a lot going on in this one. We are extending the type project and the status subgraph, which is resolvable by the ID. We know this already. We're saying that the ID is not controlled by this subgraph. It's an external value. Entity resolution has to happen in another part of the architecture. The created at is also not owned by the status service, but it is queryable and is external as well. Then we add our two properties to this subgraph, but we can only do that if we have the required at value. So we're building up this model of the router. It's essentially a DAG that says, okay, when I have this, I can do this, and this is how the whole schema resolution works. And again, this is all in production at the Raw Code Academy, so I will be showing you some queries with the service breakdown, and I'll show you the code of how we put this all together in a very nice way. Using some cool projects to do scaffolding and templating. So when it comes to building these services, you don't really need to think about this too much. You just think about the one little bit of code that is important to you. Right. Now, we covered this one. The caveats, of course. I really need to put my slides in the right order. Provides is one of these things where you do need to be very careful. When you start to denormalize your data in this way, this is where you're escaping the traditional canonical path of your server's composition. This is where most of the foot guns live and where you can start to deliver stale data to your customers. So I would just say be careful when you're using provides. And again, I'll give you examples of when to use this. But it is the biggest foot gun that people see, or when I talk to people about this approach, the one that causes them the most production issues. So what's going on is that when our query hits the router, it goes into a query planning phase. This is very much like you would get with Postgres and MySQL. Any database that you're speaking to, when you give it a SQL query or whatever language you're using to query your database, it has to break it down and work out the best way to handle the resolution for the tables and the columns. And GraphQL Federation is just the exact same, but instead of speaking to a single database, like MySQL or Postgres, we're actually doing distributed calls to each downstream subservice, which sounds pretty scary, right? I mean, why do I want all of these different paths and network hops to resolve a query? But then you're already doing microservices anyway, right? You probably already have an API gateway. You're already coming in and doing this exact same thing. But I would argue that the GraphQL approach is much more sophisticated because of the directives that we have to control how these requests are handled, cached, and optimized, etc. What the query plan is actually doing is just saying, what entities do I need and where can I fetch them from? And then it just does entity resolution. What's really nice here is it doesn't do, let's imagine we're over engineering a conference and we want to fetch all of the talks, and we say get all talks, and we wait, right? The query planner knows I only need to speak to one service, so it doesn't send a request for every talk. It sends one request and gets them all back. And even if you were to say, get me all the talks and all the attendees, again, it batches all of these together, and hopefully, and ideally, any single request to a downstream service only happens once and never happens twice. So you can get very, very good performance in caching based on this as well. And because of the entity resolution, you can use external caching systems like Redis and Valkey as well, because you never need to fetch the same entity twice unless it changes. And GraphQL has all of this built into its IDL too. It has a concept of subscriptions, meaning you can literally deliver cached values every single time, never touch the network, until the GraphQL subsystem or the subscription says, by the way, this value has now changed, because we have a very clear definition of queries and write requests. In GraphQL, write to the graph is called a mutation. However, I'm going to argue that you never use GraphQL mutations, and we'll get to that too. Now, what does this mean? Well, it means that we get all of the benefits of microservices in GraphQL. Each of these are deployed separately. It's just a very simple HTTP service. I say scale independently or not, but because there's a few things that we have to appreciate with GraphQL, I'll come back to why maybe a GraphQL read path should always be a serverless or edge-based deployment. You know, when we have access to things like Cloud Run, which does multi-region deployments, when you have access to things like Cloudflare, which deploys your simple JavaScript and SharePoint projects to over 300 POPs around the world, like, why would you not take advantage of that? Why would you stick stuff in a single region anymore? Of course, there's data sovereignty and other things to be worried about, but as they have different challenges and different concerns. Each service owns its own schema, so in theory, we can evolve this architecture very quickly. The parallel field ownership is, again, leaning back into provides. If we need to share values across subgraphs, GraphQL has directives for all of this as well. Now, the fault boundaries are very important. We never want to have GraphQL respond to a request or fail a request just because one service is down. This is something that we struggle with HTTP REST-based requests as well and API gateways. How do we do service degradation? How do we handle partial responses? And all of this is codified in GraphQL. We just use directives on the properties that we're happy to not allow to fail, right? But we can say that this must happen, and we throw an error in this case, and we don't mind if these values never come back. We'll work around it at a certain point, right? We're never, when you have a single GraphQL query hitting for a whole complex graph of points, we're willing to lose some of it if that is down. So you can actually codify all of this. And again, this is really difficult to do with HTTP. Okay, so from this diagram, I just want to highlight that you can cache at the router layer, the service layer, and the column layer. GraphQL doesn't really mind. You can throw caches everywhere that you want, and it's just such a great model as well. So yeah, I very permissively use caching across my entire architecture. And I do it in memory. You don't need to use Redis, but again, it comes down to your architecture. So when we have multi-tiered caching, we can cache at any single point within the graph. We have access to CDNs and service, and we can reduce latency. I mean, you can hit any Cloudflare POP in less than 50 milliseconds anywhere in the world, right? This is fantastic for read traffic. So if we're going to adopt GraphQL Federation, I'm going to say that you should probably be using CQRS as well. Everyone familiar with CQRS? Good. I mean, that's fantastic right off the bat. CQRS just means that we should understand that our write paths and our read paths are different. And sometimes we do this with projections for read data, and we have an optimized write model. Because let's face it, right? We've all been doing this for a number of years. You've been taught fifth normal form. We optimize all of our database for write path, minimizing how much bytes we risk to disks and duplication and all of that. But then our applications are all read traffic heavy and usually barely any write. So why have we been optimizing for this write path for so many years? And CQRS allows us to say, well, let's just have different read and write paths with different data stores using read projections if you want. And GraphQL fits this model fantastically as well. So I would say if you are doing GraphQL Federation, just try and be CQRS as much as possible and handle your writes completely differently. And this means you can leverage Akamai's network, Cloudflare's network, multi-region cloud run deployments, whatever you want. Just throw your read path to as many locations as possible, because you can cache it not just at the service level, the column level, but at regions and cities, whatever you need to do there as well. Now, this does mean that the write side of this is very complicated. So given the example that we've already shown, where we have the concept of a project and we have issues and we have comments, if I need to be able to, in fact, it's actually quite easy. If I need to write a comment, I write to the comment service. Let's talk about the Raw Code Academy architecture, and then maybe I'll show the code first. You need something like sagas or workflows or durable execution to be able to do the write paths, because if I'm going to populate, or say, this is a completely crazy scenario, but I need to create a project and I need to create an issue and a comment all in one request, because I don't know why. That is a distributed write across 3 different microservices that we need durable execution to say if any of these fails, we probably want to roll it back and retry that transaction. Durable execution is a fantastic model for this. You should be looking at things like temporal, cadence, which just joined the CNCF, restate if you're into the Rust end of things. There's loads of tools that do this too. Like in 2025, it has been the best time ever to over-engineer your architectures. Of course, that's not the message that I want you to take back to your bosses, because that's not going to look too good. But we can do things differently, for sure. All right, let's take a look at the Raw Code Academy. Is that big enough? Can you read at the back? Okay, cool. So the Raw Code Academy is my education platform. If I come to the website, which isn't auto-completing, that's wonderful. You click on videos. You can see all the videos. You can click on one, et cetera, right? This is all handled via GraphQL. The request looks something like this, where we say, OK, let's fetch all the videos. Videos have a title. And in fact, if we do this phase by phase, and I will say this might not be terribly fast right now, because I was breaking things earlier. But we can fetch all the titles. This is one request, going to the router, speaking to one service, simple. Then we can add on technologies. This is actually a separate service called the technology service, which just has a bunch of services. That's a technology service which has a list of technologies. There's then an extra service, so I'm now doing a join table as a microservice in this architecture, and I can already see people looking at me funny, which just has the technology ID and the video ID. And if I request this, again, I've been breaking things, so it's now going to be much slower. Yeah, not normally that slow. Yeah, okay, so we've got some down here. We can see we've got some episodes have been tagged with the correct technologies. I have to do some metadata work for sure. But that works. Now things are going to get a little bit more weird. Sometimes a video can be associated with a show. This makes it an episode of a show. And a show also has a name, but it also has hosts. So this is now getting very complex, because our episodes is a service, our shows is a service, show hosts is a service. So actually, this single request here is now going down to at least 7 different microservices within the architecture and providing this response on the right. And again, my performance. I always say the performance in the system is great, and then I show it slow. I really need to fix some stuff in my infrastructure, but this is not a GraphQL problem per se. Now we can see that Cloud Native Compass, it's got 2 hosts, and shows also have a code. Oh, no, I broke it. Oh, ID. So yeah, there's lots going on here, but what does this mean from a code perspective? And this is where I think things get kind of interesting. Maybe I'll make that bigger. Oh, it doesn't do the sidebar. That's the problem. All right, okay. A UI font. Perfect. Oh, that's a really annoying way of doing it. Okay, so this is the people biographies. So one of the things I had in microservice really early was the concept of a people database, right? Every time someone joins an episode, we store them in the people database. It has their name, it has their GitHub handle, and a bunch of other things. And then at some point, I went, okay, I want them to be able to manage their own biographies. And I thought, okay, we'll do this as a service. I could have extended the people service, but I made it its own service. And to do this, all you need is a database definition. So I'm using Drizzle here in TypeScript. I have services in Rust, I have services in Elixir, I have services in whatever, right? It doesn't matter. I like TypeScript for this approach because I can deploy it to Cloudflare, and again, I like taking advantage of their edge compute network. So we just have a person ID and they have a biography. There is, of course, a migration. I've actually considered ditching the migrations altogether, and just every time I start the service, just making sure everything, the tables exist, and failing if they don't. But the migrations work, it's not a problem. I don't really need this Zod, but I do create a Zod type so that other services can have access to that, and I publish them on NPM as well for myself. So that's the data model, very simple. And then we have a schema for GraphQL. Now this builds on all of the Drizzle stuff that we're doing at the data model layer. We're using a system called Pothos. Again, this is a TypeScript GraphQL plugin, integrates with Drizzle and with Zod. So I define my types once in the database, and then I can actually reuse those types to export the GraphQL type. But normally I don't want to export everything, or I want to change the schema slightly for the GraphQL interface. So here I'm just saying, yes, you can query people. This is an external field. So this is how we do the directive in TypeScript rather than as a @ in the SDL. And then we have a biography field, which is resolved by just querying our database. So this is, basically less than 50 lines of code minus some of the scaffolding and import statements. And that's it. That's me extended this. I can just deploy this to Cloudflare, register the SDL with the router, and my job is done. Now, there's actually quite a lot more going on here, but because I have standardized on this as my read path, I use Progen to scaffold the rest. If you're not familiar with Progen, it's just a project that came out of CDK and AWS. I've defined something called a platform service, and what actually happens is if I just run Progen RC, it does all the plumbing. We get the Wrangler deployment config. We get the publish script, which writes the SDL to send to our router. We get a main.ts, which just sets up the fetch handler for Cloudflare. And then the data model, nothing really changes. This is still the exact same. So you get to optimize how quickly it is. I think anyone in this room could write a database Drizzle schema and a GraphQL export in less than 30 minutes, easily. And now they've been able to extend and add new functionality to their system, which is a very nice approach. The last thing I will show is when you go to api.rawcodeacademy, you can do this on your own. Oh, no, actually, let's go to Cosmo so you can see the SDL. Log in. So Cosmo is a managed service. It's where I run my production API. This is where all the schema checks and contracts are agreed to. So I can actually never deploy a failed schema because the composition checks would fail. As you can see here, it says successful. So currently my API is actually OK. We get to look at a graph of the top 5 endpoints. And if we come over here, you can see all the subgraphs. So there's the fact that I have emoji reactions on videos as a thing I added. So you can go and click a thumb up on it. We have show host, which is a distributed join table. We have the video technologies, which you've seen in the query, and even video links. So everything that we're doing is just adding on these columns to the API. And if you need to see the schema SDL, it's all stitched together very nicely here. This could be downloaded, transferred to other types. You can do whatever you want. It's a very powerful system that I think makes microservices easier today. Now, I think the take-homes here are obviously, please don't go and write every column as a microservice, but do understand that GraphQL Federation enables that to exist, and you can extend your application in this way. And not only that, I just think GraphQL is a really nice IDL for defining how your microservice composition works, or even your architecture in general. And it's almost a ubiquitous language that can be shared across any team to understand it as well. It's very easy to read and understand. With Federation, we can scale this to whatever silly deployment mechanism you want. For me, that's columns as I go, and I'm going to keep pushing this more and more. We're currently at around 48 microservices, and I want to get this to many hundreds over the next 12 months. API gateways are great, but even better in GraphQL because we can use the directives to handle routing, performance characteristics. I mean, you can even do failure scenarios where you say if this service is down, fetch from this cache, or if this service is down, go to this service. You can do deprecations and a whole bunch of other things to have it. No. You can actually mark fields as deprecated in the GraphQL API, and you can also say it's been overwritten. Please, whenever someone asks for this column, go fetch this column instead, or go to this service. Go read the specification for GraphQL is fantastic and allows you to do anything that you can imagine in a very clever way. All right, thank you so much for your attention. I know this has been a bit weird, but I hope you see the power in GraphQL Federation, and I hope you kick the tires on it for yourself. And I'm happy to answer any questions.
All right, thank you so much, David. Any question for David? Well, there has to be something.
How do you handle read optimization for like long lists of projects, and you want the status for all those projects?
Yeah, so you can start off very simply and have, so the POFA system that I said there goes directly to a SQLite database and does a select, which is of course very, very fast. But if you decide that you need to optimize that further, you can then have an in-memory cache within the service. But you can also have the router go and speak to Valkey or Redis or anything else with the entity resolution, and then it will only go to your service for anything that fails. So you can use a distributed network cache if you need to. You really get to decide whatever you want. The GraphQL semantics and the directives allow you to just say, this is the flow that I want for reading data from the system, and then it makes it happen. So I typically just use SQLite because it's really, really fast and on disk. But in-memory cache is what I go to next, and then at some point I will bring in, I use Valkey quite a lot as well, so that's there as well. Did that answer your question, or do you need more details?
Somehow, I was more looking for like batch requests and stuff like that.
Like what, sorry?
Batch requesting for this.
That all happens by default, sorry. Yeah, the GraphQL router does all of these optimizations for you, so it never queries the same service twice. It does one batch request for every entity that it has to resolve. This is all part of the query planning step. So when you send a query, it does a query plan, breaks it down to entities, batches every request together, so one request goes to each sub-service. It also has a cache at that layer, and with the provides caveats that I kind of hopefully covered, we can say instead of going to the video technology service, the video service has a cache with the technologies on it, and it will return it directly from there, even with just one extra network hop. All configured via the GraphQL directives, where I define how the caching lives, each tier in the cache, and the batching is just something that happens by default by the router.
Thank you.
All right. More questions?
I have two, actually. Yeah, one, how do you track the errors in these kind of federation and microservice down the stream? And second, you point out the best practices on migration there, but all of them was, don't do this, don't do this. Do you have one that we should do, and a recommendation?
Okay, let's tackle the first question, and I might ask for more context on the second one. I forgot the first question. The error tracking, yeah. So I'm using Cosmo Router. It has built-in open telemetry. So every time you go to a different service, it's automatically inserting a trace parent, which is just a W3G official way to do distributed tracing. All this comes back to the router, and I can actually go in the Cosmo interface there, enter any trace ID, and see that information for the last, I think it's only 24 hours I have on my plan. But you can also export all of that to your own, if you've got like an LGTM, Grafana, Tempo set up, you could write all of that information there. So you have distributed tracing at every section of your subgraph and every microservice. And of course, if you have open telemetry in your database requests and everything else, that all comes together and you get a pretty holistic look at your traffic across the entire service.
And who creates this ID?
The router does that for you. So any request that comes into my GraphQL router, it attaches a traced parent, and then that is propagated down to every single request within it, and then that's pushed back up to the router where it writes it all to the OpenTelemetry stack. So you get very good visibility. They also have something called Arc, which I think is automatic something. It basically allows you to visualize your cache paths and your service paths and where they're all going. You can identify hot paths within it and say, okay, we need to optimize this further because the responses here are too slow. It has alerts that you can configure in the router layer as well. They're all very powerful. I mean, there's only maybe 2 or 3 companies that are VC funded and doing GraphQL Federation routers, but they're now competing against each other to make this the safest and most performance way to do this. So it doesn't matter if you're using Cosmo, it doesn't matter if you're using Apollo, and it doesn't matter if you're using GraphQL Hive. They're all focused solely on this and solving this problem because this is the challenge. We work on, again, the easy stuff. We push the complexity to the router, and then it's not, well, it's our problem, but other people are paid to make it faster. So hopefully that helps. What was your second question? I think the point was GraphQL, like SQL migrations are, you're talking about the SQL migrations, right? Yeah. So we all know they're not something we lose sleep over, hopefully, but there are a bunch of rules that you have to know, like you never rename a column, you always add a column. And then we do this for backwards compatibility. I'm not trying to convince people not to do SQL migrations. Like, if that's your approach, then do it. Understand the rules and do it safely. But I feel that those rules are in place to give us backwards compatibility. And I think with GraphQL, we don't need that. We have schema contracts that make sure we can always satisfy old requests, but we can also just say, no, don't do this anymore, and forward them over here, right? So we can kind of shape and evolve that with the GraphQL IDL, rather than having to have this internal knowledge within our teams that this is how we do SQL migrations. And while SQL migrations are well documented today with best practice, I just think they're irrelevant and we should move beyond it to newer architectures. I know this is new. GraphQL Federation is not something that I see backend teams or cloud native teams doing. So I just want to raise awareness that this is a really powerful approach to do microservices.